test number 1. This one is on limits, continuity, derivatives by first principles. So in grade 12, when you're taking up calculus, you're going to run into, I'm sure, some kind of a test. So I created a test here for you. It's not an easy one at all. I made it on purpose with regards to some of the harder questions. So this should challenge you. As usual, in all the tests that I do, in the show notes, I'll attach the link to the PDF file so that you can download all the different questions and then try it on your own, and then hopefully come back to the video and watch it. I'm sure it's going to be a long video because the questions are not easy. So let's dive in. Okay, so question number 1, find the limit if it exists. Okay, so here it is. Here's the first one, okay, that we're going to do. I'm going to copy this down. I'll bring it down here for us. So this is a limit as x is approaching to 0, and notice that we have kind of a root minus another root divided by x. Now I already can see that we're going to run into trouble here, because as x is approaching to 0, then clearly the denominator, as we take the limit of that, is going to be approaching 0 as well. Now in the numerator, okay, if we do the same thing, so if we take the limit of the numerator, you're going to notice that we're going to get the square root of 3 minus, okay, so that x's are going to be approaching 0, so basically it's approaching square root of 3 minus, and then you have another, okay, x plus 3, and that's also going to be approaching the square root of 3. So, you know, we're going to get square root of 3 minus the square root of 3, which is going to be approaching 0 again. So if you try to do this, you know, you're going to get, if you just apply the limit to the numerators and denominators by the limit principles, then, or properties, you're going to get this, right? So those properties are going to lead us into that. Now I can put up a link up above there to those properties. You can walk yourself through it if you like. And now, once we get an indeterminate form, so I mentioned to you that unfortunately we can't really conclude anything. Well, it is indeterminate. However, so once this comes into play, you know, and you have to figure out if a limit exists or not, then right away you try to look for certain patterns. So there's, you know, a few things that you have. I notice whenever I do get a negative in between, you know, two particular expressions, I always think about a difference of squares to try to basically get rid of the numerator, so maybe things will cancel out for me. So that's what I'm going to apply in this case. So before I start applying the limit, let me actually do this. So I'm going to take 3 minus x, okay, so the difference of squares, so I'm going to put a plus in there. It's going to be x plus 3. Now the denominator doesn't really change for me. I'm going to do the same thing because I don't want to be changing anything. So this is kind of the little trick that we use to see if we can, you know, massage this out in some way. Now with this, then once we, you know, take the difference of squares here, then what I'm going to get is I'm going to get 3 minus x as so, minus, and then we're going to get x plus 3, so that's going to be my numerator. I'm going to just worry about the numerator for now. I'll come back to the denominator in just a moment. Now if I do this, then you'll notice that the numerator will actually nicely simplify for us. So here we're going to get 3 minus x and then minus x minus 3. So the 3 minus the 3 will cancel, so that's going to cancel with this. But we're going to get negative, I guess, 2x in the numerator. Now in the denominator, so that denominator is going to be comprised of that, and then this entire junk right here. So really what we have is negative 2x all over, and this is going to be x, and then that junk, so 3 minus x plus x plus 3. And now as we do take the limit as x is approaching to 0, so because we are approaching to 0, so we're never really at 0, so that means we can do our cancellations. right here. So that will cancel out. So we're going to get -2 on top. So the limit of -2 is just -2. And then in the denominator, so if we bring in our limit, so, if you want to do it, nicely and then utilize your properties, so you're going to get the limit of 3 minus x in there as x is approaching to 0, plus you're going to get the limit of x plus 3. And now bringing in the limit inside of those brackets, inside of that root, so this entire thing is just going to be 3, and that limit is approaching 0, so that thing is going to go to 0. So this is going to be square root of 3 plus, and then the same thing here, so the limit is applied, distributing across, so that's going to be 0 right here, and then that's going to be just a 3, so we're going to get square root of 3. So that means we have -2 all over, and this is going to be 2 square root of 3. So the 2 and the 2 cancel, so this is -1 all over the square root of 3, and that would be our limit. And that's what we would have to do. So this is one of the little tricks, utilizing difference of squares whenever you do see a possible subtraction sign, and then, funky stuff like radicals happening in here. So in this case, square roots that we have to worry about. So there you go. So that is the first one, and I told you it's not going to be an easy walk for us in here. This example is tricky as well. So if I do try to break in and utilize the limit properties and then bringing them in, so if I bring this limit inside, numerator and denominator, and then just distribute it across, so you'll notice that I'm going to get some -2 plus, and then the third root of 8 is 2. So this actually is going to give me 0, and then I'm going to get also 0 in the denominator. So that's a problem. So once again, I have indeterminate. And so I can't really use the limit properties to solve this, so I do have to massage this in some way. Let me clean this up for myself. I'm going to bring this negative right here inside. So that's going to be 2 minus... I think this looks a little better. And then I'm going to get, let me just shift this, 8 minus t. So I can just swap those two. It's still the same thing. So this doesn't really help me much. It just makes it look a little bit nicer. And now, just like in the previous example, you're going to see that within this, you might want to use the difference of squares because it's negative, right? And then you have a root. Now, the difference of squares works well on the square roots. So that works nicely and basically on even. So if this was even in some way, we can try to see if that works. But within here, if I use the difference of squares, it's not going to help me. It's not going to help me because if I... you can try it, by the way. You can try the difference of squares. You're going to see that you're not going to get rid of your root. So that's not going to work in here. So what is going to work? Well, okay, let me take, the denominator. I'm going to try to use factoring in some way. So now I know 8, okay, because it's the third root, right? Notice, third root of 8 is 2. And now notice I have 8 in there. So I can technically maybe set it up as a difference of cubes. So if I take this as a difference of cubes, so if you remember, okay, so difference of cubes told us this. If we have x squared minus, squared cubed. So if I have this, then this is just equal to x minus y multiplied by x squared. Now the sign changes here, so it's that. And this is going to be x y plus y squared. So that's the difference of cubes. If you forgot it, I'll put up a link up above there for you. You can recall that. I think it's from grade 10 or grade 11. So both difference of cubes and then sum of cubes. So you can go back to that. Now, why am I using this? Because notice I can change 8 minus t. So I can take this and call this 2 cubed, right? And then I can do this where my t, and this is, it's not, if someone shows you this, okay, it will make sense to you. If I do that, that's still t, right? The third root. And so basically what I'm doing is this 2 is now my x, and this, okay, is my y. So what I'm going to get is I'm going to get 2 minus this, and this is exactly, look, what I have in the numerator, right? That's why I was thinking about that. And then now I have to take all of this junk, okay, and put it in here. So that's going to be 2 squared plus 2 times 3, okay, that's t, and then plus third of that. Okay, so that's what I'm going to have there. So now, nicely, if I substitute back into that denominator, this is going to cancel with that because the limit is approaching 8, right? But it's not really 8. So this whole thing now is going to be limit as t is approaching 8 of 1 all over all of this junk right here. That's going to go at the denominator. And now, well, if I use the limit properties, so that's going to be 1 on top and then bringing it in here, so that's going to be just 4, bringing it into here, so that's going to be going into that t, so that's also going to be 4, and then bringing this into here, that's going to be, well, this is 2 squared is also 4. Okay, so this means the limit is 1 over 12. So that is my limit, okay, within here. That's not an easy one at all, to be honest with you. You do have to be exposed to these to see these little things and then think about, what do I have to do in order to get this going. Worst comes to worst, by the way, if you can't tell, utilize, depending on how much time you have, and then, how many marks, so typically if you wouldn't get this, you would kind of skip it over, go into the next question, see if you can work them out, and then come back to this one maybe at the end. And then worst comes to worst, actually just start substituting numbers in here if you can't see a pattern. So, remember that the limit means that you have to substitute positive numbers, so you could have substituted, very small 8, 0, 0, 0, whatever, 1 into there. That's from the right hand side. And then you can go back and then say, okay, let's substitute from the negative side, which would have been like 7, 9, 9, 9, 9, as it's approaching 8, and then see what they're starting to equal, right? If the limits equal a number. Now, of course, this is much cleaner and this is super nice, but this at least will, if you can't figure it out, at least it will tell the teacher that, you understand limits and what you would have to do. And you can do a little bit of an explanation. And I'm sure, if it's if the teacher is good and understands what you're doing, at least you'll get some marks. Maybe you won't get the full marks because they wanted you to actually show something like this, but at least you'll get something. So that's another example that we have in here. Let's take a look. This one, again, these are all kind of tough. So let's take a look at this example right here for limits. So I'm going to start pacing myself to try to do this. All right, so I notice I have a quadratic on top, quadratic at the bottom. I'm just thinking I'm probably going to have to do some kind of cancellations. Okay, so let's see this. So first thing I always do is apply the limit properties just to see. So I will distribute this limit all the way through everything. Now, what is this going to give me? -7. So 3, -7 squared, that's 49. Oh boy, 3, 49. Okay, let me just save a little bit of time here. Let's pop up the calculator. So 3 times -7, this is squared, plus, it's it's going to be 19 times negative 7. And then minus 14. Is this 0? It's 0. Okay. So that's 0. And then in the denominator, I have, what is that? 49 minus, what is this? 42 minus 7. That's another 0 there. So once again, I have indeterminate. So all of these are, kind of tough. So if this is indeterminate, now the only thing is, I am noticing that it's quadratic. So if it's quadratic, you can factor this out, right? With regards to quadratics. So you're using your skills from grade 10 and grade 11. So this is, it shows you how much those foundations matter in those earlier grades. And if you don't have them, you'll run into problems. So, quadratic, so I'm going to break this thing down. So let me do this. Okay, so it's 3 times the 14. 3 times 14, so 28, 38, what is that, 42? So negative 42, right? So if I multiply these two together, oh, that's not going to be that bad because I need 19, right? So to break it down, I need 2 numbers. So I'm going to break this down, just positive. So it's going to be positive 21. I can see this right away, and minus 2. So if I add these together, I'll get 19, and if I multiply them, I get 42. So I'm going to break this out. So this is going to be that plus 21r minus 2r minus 14. So that's that. Maybe let me swap these. So instead I'll do this. So 2 plus 21r, so that I can just use factoring. Okay, so that numerator is going to be, so I'm going to take out the r here. So this is 3r minus 2. Take out a 7, so plus 7. So that's 3r minus 2. So notice this thing is equal to 3r minus 2 times r plus 7. So that's factored out. Now the denominator, this one's easier. R squared plus 6r minus 7. So here we're going to get, so that's negative 7. So that's going to be plus 7. So I guess it's r squared plus 7r minus r minus 7. So that makes sense. I can actually, let me group this one and this one. So I'm going to get r. That's going to be r minus 1. Grouping this one and this one, take out the 7. That's r minus 1. And I get r plus 1. R plus 1. R minus 1. That's from here, right? Factored out. And then r plus 7. Okay, perfect. So in that case, so what I'll have, now I'm going to get 3r minus 2. R plus 7 all over r minus 1, r plus 7. So these two will cancel. They'll factor out. So this is as limit as r tends towards negative 7. And hopefully we'll get something good here. Okay, so if I now bring this inside here, bring this inside here, bring the limits. So that's going to be negative 21 minus 2 all over negative 7 minus 1. So minus 23 all over minus 8. So that's an ugly one. So that's 2 and 7/8. Okay, so something like that. So there we have it. So we found our limit. Okay, so this one also exists. They all seem to exist. They're just a little bit hard to grind away at. So that's another example for you. And super hard ones. Negative 2. Oh my gosh, am I going to be running into trouble here? So what do I have? So if I bring this into here, so that's negative 2 squared. So 4, 2, so that's 8 minus 10 plus 2. Oh my gosh, seriously, 8. Okay, so this is 0. And then in the denominator, yeah, 4 minus 8 plus 4, I get another 0. Okay. Okay, so, this is definitely a tough one. So what do we have here? We have another indeterminate. Again, it's quadratic, so this one shouldn't be that bad. If I break this one down, so 2x squared plus, so 4x plus x plus 2, and then in the denominator, this one's not bad. So here, this one is just x plus 2 squared. So that I can see there right off the bat. Okay, so that's not bad. All right, so this one now, I'm going to take out the 2x out of here. So that's going to be x plus 2. And plus, I guess, x plus 2 as well. So this whole thing, I will get the following. 2x plus 1, x plus 2 all over this junk. So x plus 2 and x plus 2. So that nicely cancels. So that's great. Now I'm approaching negative 2. So even if I substitute this into here, so negative 2, so that's going to be negative 4 plus 1, say negative 3, but in the denominator, I'm going to get negative 2 plus 2, which is 0. So that's undefined. Now, when we do run into undefined, then the limit doesn't exist. So, I mean, what happens there, we have some kind of probably an infinite discontinuity there. So that's what happens. While in all the other ones, we probably just have a removable discontinuity, okay, in all of those. So, great set of questions. So this one, limit does not exist. So if you do run in, okay, and you get undefined, there is nothing else that you can do. If you get 0 over 0, you can massage things out, as you saw. But if you get a number divided by a 0, which is undefined, it means there's no limit. Okay, so the limit does not exist. So that was question number 1, and a really, really hard one. As you can see, it took us quite a lot of time to try to complete. Okay, let's